Alright, next we'll talk about cylinders. Cylinders have two identical circular bases. You could describe a cylinder as what you get if you extrude through a circle. Again, we're going to be focusing on right cylinders, which is to say that the two bases here, the circle at the top and the circle at the bottom of the cylinder, are measured at 90-degree angles to the sides of this cylinder. Or they're not measured, they are at 90-degree angles to the sides. Yeah. So with the cylinder, we can talk about the lateral surface area. In this, for some reason, the book starts to give all these formulas using, I don't know, a bunch of different individual ways. I'm not a big fan of giving you six different formulas here when they're really not needed. What I'm going to do is I'm just going to cross out the formulas that I'm not going to be using. For lateral surface area, I'm going to use 2 pi r h. The reason this one is nice is because this one actually relates very closely to, if you think back to the lateral surface area of a cylinder, or of a prism rather, what the lateral surface area of the prism said, if you take the perimeter of your base and you multiply that by your height, that's how you get your lateral surface area. It said L equals P times H. And that's essentially what this is doing, except when we're talking about a circle, instead of calling it the perimeter, well, we don't call it the perimeter, we call it the circumference. I guess they called it C times H here. But the circumference is 2 pi r. Oops, I didn't circle the r there. The circumference of a circle is 2 pi r. So you can see we end up taking the circumference, that is the way of thinking of the perimeter of this circle, times the height. So it's essentially the same formula as this lateral surface area is equal to the perimeter times the height. I'm all about trying to figure out how these things tie together and make it fewer things that you have to remember. For volume, again, they give 3 different measurements for the volume. I'm just going to scratch those ones out because I've already told you that you need to know pi r squared for the area of a circle, and for the volume of a cylinder. Well, the volume of for prisms, the lateral surface area was that. The volume was the area times the height, the area of the base times the height. And you can notice this pi r squared is just the area of a circle. Again, it's identical. It's the same formula as for a prism. Only when we're talking about circles, we use, we end up having to use a little bit different formulas for the actual area of the circle. So you can see of all these formulas, I recommend you have just these 2. I don't really see the necessity of having so many different formulas. Alright, so you can visualize why this ends up working. If you take a piece of paper and wrap it around a soda can, you'll notice that, or if you just wrap it around in a circle, the piece of paper is a rectangle, and when you wrap it around in a circle, you form a cylinder. So, if you were to unwrap the sides of that cylinder, again, we get a rectangle, and that's this. The distance here is circumference, pi times, it's 2 pi r. I don't know why you'd say 2 pi d. I don't like using, like I said before, I don't like using so many different versions of the same formulas if I can help it. Alright, so in any case, find the lateral surface area, the total surface area, and the volume of the given figure. Okay, so starting off, lateral surface area. The lateral surface area here is going to be, well, if we're talking about, well, whatever, I'm just going to say it's that's 2 pi r times height. It's the perimeter, or the circumference, times the height. But your circumference is, of course, 2 pi r. So, in order to use this, we need to know what the radius is. It looks like in this example we're given a diameter, so I'm going to go ahead and just say what the radius is. The radius is 11. So we get 2 times pi times 11 times the height, which is 24. 2 times pi times 11 times 24, which gives us 1658.76, whatever. This being a lateral surface area, it's going to be measured in square inches, since each of these measurements were in inches. The total surface area, S, is what we're calling the total surface area. Well, for each of these bases, the radius is 11 inches. the area of each of these bases is found by using the formula pi r squared. So pi times 11 squared. Pi times 11 is 380.1327 approximately. So that means the total surface area of this guy is going to be your lateral surface area. That's the surface area of the side. It's only really one side. But we're going to need both the top and the bottom because there's two bases here. So we're going to take L plus 2 times this area that we just found. So 1658.76 plus 2 times 380.1327, which is going to give us, I should probably round this to 2 significant digits there, or to the hundredths place, I should say. 1658.76 plus 2 times 380.1327. This will be 2419.03. Rounding it to that to the hundredths place just because that's what this one was rounded to, and I'm adding those numbers together. The volume is going to be my area times the height. This is the exact same volume as we saw when we're talking about a prism. And of course the area here, well, the area, we just found that, is 380.1327. The height is 24. So 380.1327 times 24 gives us 9123.18 approximately. I'm not rounding to any particular, I'm not being careful with my rounding here at all. I'm just kind of rounding arbitrarily. Generally, it's not a good idea, but for this problem, I'm not really caring too much.